Hi everyone. In the previous session, I have derived the expression of efficiency and condition for maximum efficiency. So condition for maximum efficiency was Pi is equal to PCU, right? So we have similarly, what is the maximum efficiency? So we have also defined the maximum efficiency. So what should be the maximum efficiency for this particular condition? So we get V2I2 cos phi 2 divided by V2I2 cos phi 2 plus 2 Pi, isn't it? Okay. So it is 2Pi. Why it is 2Pi? Because in the last class we have derived the expression of efficiency as V2I2 cos phi 2 plus Pi plus PCU full load. Since PCU is equal to Pi, so we can have the equation as 2 into Pi. And remember, since we are finding the maximum efficiency, okay, so now even this I2 becomes I2M or I2 max. Okay, so this I2 becomes I2 max. So how we have obtained the graph? The graph was like this. So here if this is considered as the maximum efficiency and this is at the maximum load, so I2 max. Similarly, whenever we represent the maximum efficiency, the equation should be considered as especially this I2 must be considered as I2 maximum. So we have seen the maximum efficiency, and similarly, so we need to find out what should be the maximum load. Or to have this equation, so we know that I2 square into R2 is equal to PCU, isn't it? So you have already learned that I2 square into R2. So here, so we have just considered the equation of the maximum efficiency. So next we are going to see, so the maximum, what should be the equation of the maximum load current at maximum efficiency. So initially to start with, so we need to have the equation as I2 square into R2 is equal to PCU. So we know this, and of course we know that PCU is equal to Pi. So now I am going to replace this PCU as Pi. And so one more assumption that I2 is equal to I2M. So what is this M indicate? This is for the maximum load current. So I2M. And so now I am going to replace this as I2, that is I2 as I2M, right? And so what is I2M? If I consider only I2M, so this becomes Pi divided by R2. So since we have square here, and to remove that square, so we get I2M is equal to square root of Pi by R2. Now I am going to divide this equation, okay, both left hand side and right hand side equation. Okay, so anyway, before that, so let us call this equation as 1. Now divide equation 1 by I2, so I2 full load. So that means I2M divided by I2 full load, okay, and which is equal to, again, so because I am dividing both left hand side and right hand side equation by I2 full load. So this becomes what? I2 full load, so into square root of Pi divided by R2. So remember we are deriving the expression of the load current that is at maximum efficiency. So what is I2M? I2M is the load current at maximum efficiency. So that is why we have represented this as M. Okay, now what is I2M? I2M is equal to, so now I am going to, okay, so anyway I will write the same expression in the left hand side, and so include this I2 full load into this square root. So we get, so square root of Pi divided by I2 square full load into R2, right? And here in the next step, so we can have I2M divided by I2 full load is equal to, so square root of Pi divided by, so what is I2 square full load into R2? I2 square full load into R2, because we know that I2 square into R2 is nothing but PCU, right? So I2 square full load into R2 is nothing but PCU full load, remember? So now we are replacing this term as PCU full load, and now this can be written as I2M is equal to, so now I am taking only I2M in the left hand side, so I2 full load, so square root of Pi divided by PCU full load. So what is this equation called? This equation gives the load current at maximum efficiency. So remember, I2 is nothing but the load current, and we have obtained the load current at maximum efficiency. So here after defining the full load current at maximum efficiency, so here we are going to consider the load or kVA. So remember, so here we are going to consider load or kVA supplied at maximum efficiency. So far you have learnt about the maximum efficiency equation and the full load current at maximum efficiency. So next we are going to see the load or kVA supplied at maximum efficiency. And remember here for constant V2, okay, so assuming that the voltage remains same, so for constant V2, kVA supplied is a function of the load current. So remember again, the kVA supplied is a function of the load current. So with this definition, so we are going to have the equation as, that is load or kVA supplied at maximum efficiency, which is equal to I2 max, that is I2M, so V2. So what is I2M? Which is the full load current at maximum efficiency. Okay. So now you can substitute this equation here. So if we substitute equation, so here, so we get V2, so into I2 full load, so square root of Pi divided by PCU full load, right? So here we have obtained V2 into I2 full load. I have just substituted this I2M here. So I2 full load, so square root of Pi divided by PCU full load. What is this V2 into I2 full load? So here we can consider V2 into I2 full load as, okay, so this as VA rating. So as I have already discussed this VA rating in the problems, like VA rating is nothing but V into I. Okay. And now substituting the same here, so we get, so VA rating, replacing this V2 into I2 full load as VA rating into square root of Pi divided by PCU full load. So this is nothing but what? This is the load or kVA at maximum efficiency. So remember, this is not the equation of the maximum efficiency, it is a load at maximum efficiency. It is a load at maximum efficiency. Next we have voltage regulation of a transformer. So in voltage regulation of a transformer, or it is defined, okay, so it is defined as the secondary voltage, the change in secondary voltage from no load to full load. So remember, it is defined as voltage regulation is nothing but, or it is defined as, okay, the change in the secondary voltage, so from no load to full load, right? So here as you can see in this equation, so voltage regulation, of course it should be represented in terms of percentage. So as I have already indicated, so the change in secondary voltage from no load to full load, right? So VNL is nothing but, it is the no load voltage, and this is for full load. So FL indicates the full load voltage, so divided by, so here the full load voltage, and of course it should be multiplied by 100 because we have represented in percentage. So voltage regulation is the ratio of the change in no load to full load to this full load. And here, so remember, this is meant for up regulation. There are two types of voltage regulations here. So one is up voltage regulation and another one is down voltage regulation. So remember, in up voltage regulation, so we have VNL minus VFL divided by VFL. And as I have already told you, it is change in the secondary voltage. So what are the secondary voltage? And remember this V no load, okay, so without any load, this voltage can be represented as E2. That means E2 is nothing but the voltage induced in the secondary winding. So E2 minus and this V2. So this is the voltage with full load, and that means full load means the voltage which we measure at the load. The voltage which we measure at the load, we call it as full load. So E2 minus V2 divided by V2. So again it is full load. And remember, this equation is meant for up voltage regulation, right? And similarly, so we can also have the same expression for down regulation. So we can have for down regulation. Okay, so this numerator remains same, but in the denominator, instead of having the full load, so we will be having no load. Okay, this is the only difference between the up regulation and up voltage regulation and down voltage regulation. So in the denominator you will find, so V no load, and of course, so here V no load means this becomes E2. Okay, and this is for the down voltage regulation. And the importance of voltage regulation. So the importance of voltage regulation is less the regulation, better is the performance. So remember, less the regulation, better is the performance. And this definition so can also be called as per unit regulation. So now we shall move on to the problem on problems on efficiency. Okay, so till now we have understood the problems on this VA rating and so EMF equation of a transformer. So now we shall move on to the problems on efficiency of a transformer. Okay, so look at the problem carefully. So based on the statement, so we need to write down the given data. So here in 25 kVA, look at the problem carefully. So one by one, in 25 kVA. So remember, this is the value. Since, so please look at the unit here. So the unit is kVA. Okay, so now this is nothing but VA rating. This is nothing but VA rating, which is equal to 25 kVA. So in this kind of problem, so first you look at the unit. So based on the unit, so we need to decide, so which value is this. So VA rating is 25 kVA, and here we have 2000 so slash 200 volts. So remember, we have 2000 slash 200 volts. So this is nothing but so E1, which is equal to 2000. Okay, or we can also consider this as so V1, and similarly so V2 is equal to 200 volts, right? So they have given two voltages here. And next is the iron and the full load copper loss. Right, the iron and the full load copper losses are so 350 watts. So now the 350 watts is the value of the iron loss, because they have given iron and full load copper loss. So remember, Pi is equal to 350 watts. 350 watts, and so full load copper loss is nothing but PCU full load. So remember, it is PCU full load, which is equal to 400 watts. 400 watts respectively. Now what is the question here? So or what we need to find out, calculate the efficiency of a transformer so at unity power factor. So remember, they have provided one more value, which is unity power factor. Whenever they provide unity power factor, or in a short form, okay, whenever they provide UPF, which is understood that cos phi is equal to 1, because cos phi is nothing but power factor. So when they mention UPF or unity power factor, it is understood that cos phi is equal to unity, or cos phi is equal to 1. Okay, so based on this statement, we can write it as cos phi as 1. And similarly at half and 3/4 full load. So now we need to find out the efficiency at half load and 3/4 full load. So as I have already explained, the concept of this fractional load and the full load, so based on that we need to have the equation. Okay, so let us calculate the value of that is efficiency at half load. Okay, so remember, whenever we find the efficiency for half load, so N should be considered. What is N? N is nothing but the fractional load. As we have already defined in the earlier classes, N is defined as the fractional load. And what is the fraction here? So fraction they have provided as half. Okay, half of the full load. So that means, which is equal to, so straight away we can write it as 0.5. Okay, that means half is nothing but 1/2, or 1/2 so can be considered as 0.5. And here, what is the efficiency equation? Efficiency. So this is N and this is eta. So don't get confused with these two terms. So this is eta in terms of percentage. And so as we know the efficiency equation, this is nothing but, so here V2I2 cos phi 2, right? V2I2, so cos phi 2, so divided by, okay, and before that we need to have, because we are finding the efficiency for the fractional load considering this N. So N into V2I2 cos phi 2, so N into, or so V2I2 cos phi 2, right? And instead of having this V2I2, so we can also have, straight away we can also have VA rating. So I'll write one more equation, which is N into VA rating into cos phi 2, okay, so divided by, so instead of considering V2I2, straight away you can have VA rating. So again N into VA rating cos phi 2, right? So cos phi 2 plus, or so we can have only cos phi. So plus what, which is Pi. What is the next term? Pi plus N square into PCU full load, right? So this is the equation of the efficiency of a transformer, that is for the fractional load, considering this N in the equation. So now we need to substitute all the values here. So all the values are provided in the problem. So what is N? See, remember we are finding the efficiency value for the half load. So what is the value of N? N is equal to 0.5. So substitute N is equal to 0.5 here. So 0.5 into, so what is VA rating? So VA rating is also given, which is 25 into 1000. Why it is 1000? Because we have K. So VA is the unit. So 25 into 1000 into, so what is cos phi? So cos phi is equal to 1. So you need not to write cos phi 2, even you can consider only cos phi. So VA rating cos phi, and so it is 1 divided by, and of course again N is equal to 0.5 into, so 25 into 1000, okay, so into 1, because cos phi is 1 plus, and what is Pi? Pi is equal to, so what is Pi? Pi is equal to 350 watts. So 350 watts plus, and what is N square? N is equal to 0.5. So if you just square it, so write this N square, which is 0.5 whole square, into what is PCU full load, because they have clearly given the full load copper loss. Copper loss is 400 watts. So PCU full load is nothing but 400 watts. So into 400. So now simplify this expression. So after simplification, that is in terms of, remember in terms of percentage means, so we need to multiply this with 100. Okay, so multiply this value with 100, so we can express efficiency in terms of percentage. So we would be getting, so 96.52, as I have already written here. So this is for the efficiency for half load. So here we can write it as efficiency at, so 0.5, that is half load is equal to 96.52%, right? So this is how we calculate the efficiency for half load. And similarly in the same way, so we can have all the values except N is equal N value, that is for the 3/4 full load. So because here we need to calculate two values, one is for the half load and another one is, so one is for the half load and another one is 3/4 full load. So what is 3/4 of the full load? As I have already defined, N is a fractional load. So N is nothing but the actual load divided by, according to the definition, so actual load divided by full load. Okay, so what is the actual load, which is 3/4, okay, 0.75 divided by full load is 1. So finally what we would be getting, so N is equal to 0.75. And remember this, even this load, the fractional load, that N value varies from 0 to 1. So N is equal to 0.75. So we need to find out efficiency for the 3/4 full load. by considering the same equation, but so instead of having 0.5 in this equation, so we need to have n is equal to 0.75. So calculate the same, calculate or simplify the same. So finally, so we would be getting n, that is eta for 0.75, that is for the 3/4 full load as 97.02. So later you can verify this value, so which is 97.02. So you can follow the same steps. Now we shall see the next problem. So on the efficiency, here a 500 kVA. So remember, this is the value of VA rating. So VA rating is equal to 500 kVA, right? Transformer has an efficiency of 92% of full load. So here, so they have provided the value of efficiency. So value of efficiency at percentage, which is equal to, so 92%, right, of full load. So full load means, see here they have given the efficiency value for the value of, that is considering n is equal to 1, because they have clearly given it is for, that is of full load. Okay, considering n is equal to 1 and unity power factor. So that means cos phi is equal to 1, cos phi is equal to 1. It is clearly given unity power factor cos phi is equal to 1, and the same efficiency 92% at half load. So considering again eta is equal to 92%, right? So that is at half full load. So at half full load means n is equal to 0.5. Then what is power factor here? So power factor is 0.9. So cos phi is equal to 0.9. Okay, I hope it is clear how to write the data. So once again I will read the problem. So a 500 kVA, so VA rating value is provided. Transformer has an efficiency of 92% of full load. 92% of full load, that is n is equal to 1 and unity power factor, right? So now this value is applicable for two values. One is for the full load and another one for at half full load. That means the same value should be written, that is for the half full load and the power factor as 0.9, right? Now, so only they have given these two values, and in the next case we need to find out, so the efficiency or determine its efficiency at 80% of full load. So remember, it is 80% of, so we need to find out the efficiency at 80% of full load, 80% of full load, and so 0.95 power factor. Anyway, so to find the efficiency of a transformer at this 80% of full load and for this particular power factor, so we need to have the copper loss and iron loss, right? So we need to have the values of the copper loss and iron loss. So to find the copper loss and iron loss in terms of power, so we need to have these values to find Pi and PCU. So how do we calculate? So write the equation. So the equation is, we know that eta is equal to so n into VA rating cos phi, so divided by n into VA rating cos phi plus Pi plus n square into PCU, full load, right? So this is the equation. Now substitute the first value. So what is eta here? Eta is equal to, so in terms of, so percentage they have given. So remember, whenever we substitute the eta value, so it should be converted to this fraction. So 0.92, that is from percentage to fraction. So 0.92, and which is equal to, so what is n value? N is equal to 1. And what is VA rating? VA rating is 500 kVA. That is 500 into 1000 into, so what is cos phi? So in the first case I am talking about, so cos phi is equal to 1, cos phi is 1 divided by same 1 into, so 500 into 1000 into 1, so plus Pi plus, so what is n value? N is equal to 1. So here we get PCU full load. And here after simplification, so we get Pi plus PCU, because only these two are the unknown values, Pi and PCU. So here considering P unknown values at the left hand side, Pi plus PCU is equal to, so here 43,000, so 472.26. Right. So this is only for the first case I am talking about. So only for the first case, considering only the first case values. And similarly, so keeping this equation or considering this equation as 1, and so in the next step, so we need to have the second case values. In the second case values, considering n is equal to 0.5. So now I am just replacing. So here this remains same, the efficiency remains same, which is again 92%. And here in the second case, n becomes 0.5. Okay, so 0.5 into 500 k, that is 1000 into. So what is the power factor? Power factor is 0.9. So instead of 1, earlier case it was 1, but here we are having 0.9. So we are just replacing this value, that is n as 0.5 and the power factor as 0.9. Power factor as 0.9. And so simplify the same expression. So after simplification, so we get Pi plus 0.25, and remember, so one more value is missing here. So here considering n as 0.5. So if we consider n as 0.5, that is 0.5 square, so we get 0.25. Okay. So after simplifying this expression, so we would be getting Pi plus 0.25 PCU is equal to, so 19,000. So 565.21739. So considering this equation as 2. Okay. I hope the steps are clear. In the first case, we are having these values to have the first equation, which is Pi plus PCU, and in the second case, we are having these values, okay, to find or to have this equation, it is equation 2. And so here now solve equation 1 and 2. Okay, so solve equation 1 and 2 after simplification. So we get the values of Pi and PCU, right? So we get these two values. So here we have calculated so the values of Pi and PCU. So Pi is equal to 11594.2029 watts and PCU as 31884.057 watts. But the question is, so here determine its efficiency. So look at the question once again. So determine its efficiency at 80% of full load. At 80% of full load. So what is this 80% of full load? So remember, 80% of full load means n is equal to 0.8. So the when n value can be so given as, so remember, n value can be given in terms of percentage or in terms of the fraction, right? So n value here they are provided as 80% of full load. Don't get confused with the efficiency. Once it is given as, so percent means don't get confused, this is the efficiency value. This is 80% of full load. That means the value, it is the value of n. N is equal to 0.8, or this can be asked, this can be mentioned as, so n as half of the full load or 3/4 of the full load, sometimes the 1/4 of the full load. Remember, half of the full load means n becomes 0.5 and 1/4 of the full load means 0.25, and so 3/4 of the full load means n is equal to 0.75. So sometimes it could be asked or it could be considered as 80% or some 20% or whatever. So 80% of the full load. So n becomes 0.8 and the power factor as cos phi is equal to 0.95. Right. So now these values are given here, and now substitute all these values to calculate the efficiency. So we know that efficiency is equal to, so what is efficiency equation? N VA rating cos phi, so divided by, so n into VA rating, so into cos phi plus Pi plus, so we have n square into PCU full load, right? So this is the equation. Now substitute all the values which are provided in the problem. So N is nothing but 0.8 and VA rating is also given in the problem, which is 500 K. So into cos phi. So what is cos phi? Which is 0.95. So divided by, so substitute all the values which you have already considered here. So plus Pi. So substitute the value of Pi and substitute. So of course what is N square? N is equal to 0.8. So take 0.8 whole square. So PCU full load. So substitute this value. So after substituting all the values and after simplifying this expression, so we would be getting efficiency at 80% of the full load. So that means eta at 0.8 as 92.23%. So we need to multiply this with 100 because we are trying to express this in terms of percentage. So finally we get 92.23% as the efficiency. Thank you.